I want to welcome everyone to attending this presentation entitled Big Data and NoSQL for Oracle DBAs. My name is Armin Rawls. I'll be facilitating this in conjunction with Michael Schrader. A little bit about Neover if you're not familiar with us. We are a provider for hosting and managed services. Our company does everything from infrastructure down to database management, monitoring and management of those, and even the infrastructure as well, storage, network. Founded in 2001, we're headquartered in Reston, Virginia, 24/7 NOC in the data center here local. And basically cover every bit of the architecture, engineer-wise and architect-wise for databases, network, storage, servers, things like that. Some of our core offerings and expertise is in the consulting area, where we do consulting for any of those things I described earlier, where we actually help you either architect it and design it, or we come in and do consulting for assessments, security, best practices, things like that throughout the infrastructure. We offer cloud solutions, private, public clouds. We do the managed services across that database, and as I mentioned earlier, security.
Okay, Armin, I'm going to take over from here. A little bit about my background. I'm an Oracle certified professional. I've been around since about 1987, so I started out on the later releases, version 5 of Oracle. And I'm a frequent speaker at some of the major conferences, such as HIMSS, Oracle Open World. You might have seen me there. I've been fairly fortunate that I've been able to publish 2 books, one on Oracle data warehousing and the other one on Oracle OLAP. And so I've been around for Oracle for quite a long time, and I've been around big data for about 3 or 4 years now. And what I want to do with this presentation is kind of get an idea of, for the Oracle people, about big data and NoSQL and what it means. Now, we're going to have questions, so I'd like to keep the questions at the end of the presentation. So please type in your questions at the text box or hold them until the end of the presentation. So a little bit overall about the presentation. Big data and NoSQL allows us to scale right now to volumes that just simply weren't possible with traditional RDBMSs like Oracle. And we're able to do them at a lower cost as well as in less time. Now, this presentation, what I want to do is I want to give you kind of an idea about big data, but I'm going to do it in terms of an Oracle DBA. So I'm going to try and relate the Oracle DBA terms to the Hadoop terms. In addition, what I want to do is go over a little bit about the Oracle in-memory database option. The Oracle in-memory database option is really kind of a cool feature of Oracle. What it does is it allows you to turn your Oracle RDBMS essentially into a NoSQL database. So you get all the benefits of NoSQL, but at the same time you still have your RDBMS. So if you want to have transactional systems on top of your database, you can as well. So what is big data? Well, big data, you've probably seen this slide before. It's an IBM slide, and it talks about the 4 V's of big data. So volume, velocity, we're getting things in real time now. Variety, we have a variety of different data types. We have both structured and unstructured data types, which we didn't get as much of the unstructured data types as we do now. And also, they have a fourth V here that they call veracity. So they're talking about data quality. Now, a lot of people, instead of talking about veracity, they actually talk about business value. And I like changing veracity to business value because I think it's an important aspect of big data. One example of big data that I can give you was with a CRM system that I helped implement. We were having trouble with our CRM system in that our customers would go to our website, and our website, they might have some difficulties with our website, and so what they would do is they would give us a call. However, when they gave us a call, they would get a rather junior person usually on the line, and they would have to explain what they were doing, and then they would be transferred to somebody else, and they would actually have to explain themselves again, and they might even have to be transferred again to talk to somebody else. So what we did is we actually captured the click view information, and when that individual called up, we knew what they were trying to do. Let's say if they were trying to change beneficiaries. And we were able to intercept that, and we were also able to intercept background about the particular individual. So we were able to send that person to the correct rep immediately. So instead of having to sit there and explain themselves over and over again, we would just simply have the rep say, hello, I noticed that you were on the beneficiaries page. How can I help you with that today? So one of the big V's was talking about the explosion of data. And we've all seen this, and we've all felt it. We're actually getting in terms of zettabytes of information. Now, a zettabyte is an absolutely huge number. When in the 1980s, I never even heard of a zettabyte. A zettabyte is 1,000 exabytes, and an exabyte is 1,000 petabytes, so it's 1,000,000 petabytes. To put this into context, when I first started in the industry a long time ago, I started off on an IBM mainframe, an IBM 370 158 mainframe, and our storage units were 3330s and 3350s, and these storage units at the time were pretty state-of-the-art, and they could actually store a couple hundred megabytes of information. Now, a zettabyte, to put it into context as far as what a zettabyte is, it would take a string of 3350s from here to the moon to produce a zettabyte, which is absolutely a phenomenal amount of data. So it wasn't necessarily the fact that we had huge volumes of data. It was the fact that we couldn't get access to it in a very quick manner. So not only was it the volume that caused big data to explode, but it was the access speed. So the whole idea of Hadoop is to have, instead of one server, literally have maybe 1,000 servers. And because I have 1,000 servers, I have thousands of disk drives associated with that particular cluster. I can actually get 1,000 times throughput. What I do is I break everything up and I run it in parallel. That's the whole concept of Hadoop. And that's the reason why it's taking off right now. It's not necessarily the volume of the data, but it's actually getting access to the data that has caused a lot of the big data explosions. Now, in addition, one other thing that has caused the explosion of big data has been complex data models of relational systems. We're seeing relational systems that have literally tens of thousands of tables. Sometimes you need to have a PhD in the data model to understand it. You don't want to have those complex data models in your Hadoop environment. You want to simplify things. 3NF is not going to cut it for Hadoop or a Hive environment. You want to denormalize the structures as much as possible. So we're actually getting back to the old days where you might have remembered where you have VSAM files. And the VSAM files are very, very large in nature. They might have, several thousand columns. Also, another aspect of big data, which is demanding, is we have to pick things out in real time. So when a customer calls us up, we can't wait a day to load our data warehouse to make that particular customer happy. What we have to do is we have to pick out the sad clowns from the happy clowns and figure out how to make the sad clown happy. You'll notice in this particular picture, there are two sad clowns. So in real time, we have to figure out a strategy on how to make those guys happy. In addition, we're getting new types of data. So one, we're getting things like sentiment analysis. So we're getting data from Facebook in real time as people comment about your particular product. We have clickstream information, so we can actually go out to the website and we can see what somebody has been doing. We have sensor and geographic data. So sensors are being very, very cheap now. So Walmart puts them in a lot of particular products. Also, we can see, for example, let's say if we noticed you had your iPhone on and we were detecting where you were, and you were coming to one of our stores. Maybe we give you an email message saying, hey, why don't you stop by and we can give you this particular special. We have things like server logs. And we also have unstructured data in terms of video and pictures. So before we get on going, what I want to do now is kind of describe a little bit about the Hadoop environment that you typically see out there. And you kind of see three different levels. You see a client node, you see master nodes, and then you see data, or some people call them slave nodes. Now, the client node is pretty obvious. That's just simply your PC. You might be running Hive on it, and you might be running, writing a query, and then that query would be interfacing with the master nodes and the data nodes. Now, the master node is going to tell us, it's going to have the management of the whole Hadoop cluster. So it's going to tell us things there like where your particular data is located and how much resources we might want to particularly give you. Now, the data node is the thing that's actually going to process your particular application. And the thing that's different with Hadoop is that the applications go to the data nodes, and the data doesn't go to the applications. So this is a new concept, right? So our data volumes were getting too large to transfer the data up to the application. So what we've done is we've moved the applications to the data node. Now, in a typical environment, obviously you're going to have much, much more data nodes than you are master nodes or even client nodes. Before we get into Hadoop, I want to talk about a little bit about the differences between Hadoop 1.0 and Hadoop 2.0. Hadoop 1.0 was the first release of Hadoop, and if you have a new project, you probably don't want to start it on Hadoop 1.0. You want to use Hadoop 2.0, and when I talk 2.0, I'm talking about something called Yarn, and we're going to be talking about that in just a little bit. But in Hadoop 1.0, if you started an application, let's say on your client server, you have Hive, and Hive is the SQL interface, much like SQL+. What it would do is it would send that particular SQL statement to the master node, and one particular master node, in effect, called a name node. Now, what a name node is going to do is it's going to take your program, and it's going to identify which data nodes it needs to go to solve your particular program. So let's say if you had a Hive query, in this particular case, it might identify that, hey, you have data on nodes 1, 3, and 7. So you need to send your particular application to those nodes to run it. So the name node is very, very critical. In addition to the name node, we also have something called a job tracker in Hadoop 1.0. Now, it's important to know one thing about Hadoop 1.0 with the job tracker. It is the Achilles heel of Hadoop 1.0. So you don't have high availability because if anything happens to job tracker, your whole cluster could go down. With Hadoop 2.0, we've solved that situation. We actually have the functions that job tracker was doing. We have that, but it's actually spawned off. So if anything happens, it's highly available. So a job tracker is going to be the one that actually allocates the resources to the data nodes. And then what happens is we copy the applications to the data nodes on the particular data nodes that you need. Remember that the name node told us that we needed 1, 3, and 7. So the client would actually be copying the programs down to 1, 3, and 7. And then they would start to execute, and they would return the results to the client. Now, with Hadoop 1.0, you had something called MapReduce. And MapReduce was the only framework that essentially ran on Hadoop 1.0. MapReduce, as it says, has different stages of what it performs. It's typically written in Java. However, very few people write Java MapReduce. What they do is they go to interfaces like Hive, and Hive actually generates all the MapReduce programs for us. So what I'd like to do to help describe MapReduce is kind of give you a feel for maybe a conceptual problem. Let's say it was Halloween time, and you had 3 children. And what you wanted to do was see what candy they brought home. So what you would do is you would line them up, and they would have the candy in front of them. They would have their data in front of them to write a list out of all the candy. So, you know, your first son would sit there and start writing out, okay, I have a Baby Ruth. Okay, I have a Snickers bar. That is the mapping component. So what you do is you take your application and you deliver it right to all the data nodes. And then you start executing a program. So then what they do is they finish with their list and they give your list back to you, right? So you have 3 lists now. So what you do is you sort all of these lists and then you reduce it down. So by reducing it down, you would say, okay, I have 5 Snicker bars. So you count up the number of Snicker bars, and you can consolidate that into one data value. That essentially is what MapReduce does. And it's very, very, very scalable. In Hadoop 1.0, we could scale up to several thousand nodes and literally tens of thousands of users. So that was Hadoop 1.0. However, we have now Hadoop 2.0. And the heart of 2.0 is something called Yarn. And it was written by a gentleman named Murphy, who now is employed at Hortonworks. And we're going to be talking about some of the major vendors in just a second here. But Yarn is absolutely critical. It's kind of known as like the OS of Hadoop. It's kind of like the operating system of Hadoop. And it's taken Hadoop to new levels beyond MapReduce. So with Yarn and Hadoop 2.0, we have different components. So the first component is that we now have something called a resource manager. The resource manager is going to be in charge of looking at your program and dedicating resources to that particular application. We also have node managers, and you're going to have one node manager per data node or per slave node. And that particular component is going to manage the resources. He has resources that he can give out in terms of something called containers now. Now, a container is going to have CPU and memory components to it. So that particular node manager, he's going to be able to give you a lease for your particular application in terms of CPU and memory. So if you think about that, what that means is I can give prioritization to a particular application. I could give a particular application more resources than another application. So it's one of the fundamental things that we have in an operating system, the ability to run things in terms of a priority queue. We also have on the data nodes, we have something called an application master. And that application manager is going to negotiate resources for your particular application, and it's going to tell all the resource managers that your particular application is finished when it's over. So we have huge differences between Hadoop 2.0 and Hadoop 1.0. We have a resource manager that we can actually spawn off a standby resource manager, where we couldn't do that before in Hadoop 1.0. So Hadoop 2.0 is more resilient. It's also far more scalable. Literally, we can go up to tens of thousands of data nodes. And we also have the ability to prioritize applications that we couldn't do in the past. And we can also put in there multiple different types of programs like Hbase, as opposed to just one particular MapReduce framework. So Yarn is absolutely critical to your implementation of Hadoop 2.0. So Hadoop 2.0, you have a job that you would start. It would again go to the name node, and the name node would tell you, okay, here are the particular data nodes for your query. You have to go to data node 1, you have to go to data node 3, and you have to go to data node 7. It would then go to the resource manager, and the resource manager would allocate resources. Then it would start off an application master. Then you would start to transfer your applications to the data nodes on the particular data nodes that your name node gave you. Then you would start your containers, right? So a container is a lease of an amount of CPU and memory. Notice it's not I/O. I/O is still controlled by the Hdfs system. A container only has CPU and memory as far as its ability to allocate resources. And then it finishes up and returns the results. So again, if you're starting new applications, you want to start them out on Hadoop 2.0. You don't want to go to Hadoop 1.0. You definitely want to implement Yarn. Okay, let's talk a little bit about Hive versus RDBMSs. So Hive is the SQL plus kind of equivalent of in the Hadoop world. So it's a SQL interface, and I'm going to actually be doing a demo on it. Now with Hive, it's not a good fit for OLTP, online transaction systems. If you don't want to have any transactions basically in Hadoop right now. It's really, really good for analytics. So it's a really good framework or an alternative to let's say your enterprise data warehouse. But it's a really poor match right now for your online transaction system. So one of the issues that we have with Hive or Hadoop is the ability to do in-place updates. And the reason is, in Hadoop, the data blocks, and I'll show you this in a little bit, are very, very, very large. And what I mean by that is they're instead of like 4K or 8K or 32K, they're actually in terms of megabytes. So on this particular implementation of Hortonworks that I'm going to show you, my data block size is 128 megs. So Hive is going to scale to literally hundreds and thousands of nodes. Typically, you don't see that in an Oracle RDBMS. Also, Hive is implemented, or Hadoop is implemented generally on commodity hardware, and it has very, very low cost per petabyte because of that. Now, right now, we have two big vendors that are out there. Here's a list of all the vendors that are out there, but you'll notice we have, everybody claims that they're a big data vendor right now. But there are actually two that I think are going to be the big survivors out there. So the two big survivors I think that are going to be out there are Cloudera and Hortonworks. So, but there are differences between the two, right? So Cloudera was started kind of by the management types who developed Hadoop. Hortonworks was developed more like the Dilberts of the world. Okay, the engineers actually founded Hortonworks. And they have two different philosophies. So the philosophy for Cloudera is that they want to have both open source as well as closed source. They do not believe that the pure open source model is going to generate enough income for them to survive. So what they do is they've created features in some of the open source products that they have that you have to pay for to kind of get you hooked on their particular software. Now Hortonworks is 100% open source. And if they buy or they develop a particular component that they want out in Hadoop, they make that component 100% open source. Also, there's a difference between the two in that Cloudera right now supports something called the rules-based optimizer, and right now Hortonworks goes more towards a cost-based optimizer. And this optimizer is exactly the same concept as what we had in early releases of Oracle, where we had the rules-based optimizer and then we went over to the cost-based optimizer. So with the cost-based optimizer, you have a little bit more flexibility to change your execution plans. And that's exactly like the cost-based optimizer in principle of Oracle. Now we also have something called a scheduler. And Cloudera is fundamentally on something called a fair scheduler, and Hortonworks utilized something called a capacity scheduler. Now, a fair scheduler, what it primarily tries to do is give people equal slices of the pie, versus a capacity scheduler. A capacity scheduler tries to prioritize things. So let's say, for example, that your marketing department gave you 80% of the funding for a particular cluster. And what they're coming to you with is saying, hey, wait a minute, we want priority on this cluster. We gave you the vast majority of the funds. So with the capacity scheduler, what you're able to do is create queues and able to grant prioritization over one queue over another queue. So just like in Oracle, where you have Resource Manager, and you could allocate, let's say, 80% to the marketing department, and then 10% to the finance department, and then 10% to operations, you can do the same exact thing with the capacity scheduler. Now, one reason, and you can do something similar to that with the fair scheduler, but I think it's a little bit more harder in the fair scheduler than it is with the capacity scheduler. Now, one thing that you're going to do once you start dealing with big data is your cluster. You might start out with an initial cluster of maybe 20 or 50 nodes, but you can guarantee that within a year or two, you're going to double, triple, quadruple the size of your clusters. Now, one thing that you want to think about, right, when you start implementing your clusters, one reason that you might want to go to a capacity scheduler is you want to have something called application fencing. And what application fencing does is it allows you to restrict a program to a certain number of nodes. So let's say you had SAS on your Hadoop cluster, and it was 20 nodes, and you were paying $1 million to SAS. Well, if your cluster suddenly goes to 80 nodes, well, SAS is going to come to you and say, hey, you just, 4 times bigger. We want to have, $4 million instead of $1 million. So you want to select a scheduler. You want to think about this up front, and you want to think about how you want to fence your applications, right, before it gets uncontrollable and you start writing a lot of checks. Now, also the last thing here, the differences between Cloudera and Hortonworks, is its implementation of Yarn. And there is a subtle difference. Both Cloudera and Hortonworks are fans of Yarn. However, Cloudera supports it, whereas Hortonworks actually had the guys who created it. And you can kind of see in their implementations that it's fundamentally a little different, the way they handle Yarn. Now, here's the slide that I have, which I produced, and it kind of shows you some of the common elements between Hortonworks and Cloudera. Why is this slide important? Well, let's say if you're on Cloudera right now and you're not sure which way you want to go, whether you want to go maybe to Hortonworks later on, you might want to consider utilizing Hive right now, even though Hive might be a little slower than Impala, because Impala is not a true open source, right? Cloudera controls the copyright to that. Now, they give it to you for free, but if you have any issues with it, you kind of have to go back to Cloudera. So if you implement Impala, you might be stuck with that for a while. You might be stuck with Cloudera. So you might want to go to more open source until there are other better open source products out there, like maybe Spark SQL that's coming down the pike. So one thing that you're going to need to do when you initially start your Hadoop implementation is you want to develop a reference architecture. So you want to develop an end-to-end framework. So for example, what is going to be your management and monitoring tools? Are you going to use Embroidery? Are you going to use Zookeeper? And we're going to be showing you some of these components in a little bit. Workflow, what are you going to use? Are you going to use Uzi, or do you have maybe control a particular workflow engine that you already have in there? What are you going to use for your query or your SQL interface? Is it going to be Hive? Is it going to be Impala? Is it going to be Spark SQL, or maybe even Sharp SQL? So basically what you have to do is you have to come up with your own reference architecture. This is a little simplified, but you have to have all these components. One thing that's different with RDBMSs than with big data is with big data, what you want to do is you want to have more of a polyglot type of environment, where instead of one particular database that does everything, that has kind of like the Swiss Army knife approach, you want to have a whole bunch of different components. And these components are going to be separate, and they're going to be decoupled. So, for example, Scoop. Scoop is a program, and it's very similar, I guess, to kind of like SQL Loader, if you would. What you can do is you can do imports and exports with Scoop from a database. You can take data from an Oracle database and move it into an Hadoop environment, and vice versa. If there's a new version of Scoop out there, all you have to do is take that off your picture and plug in the new version of Scoop, or maybe even it's a different product altogether. And because it's decoupled, you have no issues. You don't have any problems. So you want to develop a decoupled architecture that's flexible and agile. Now, in data modeling, there's a data framework called Lambda, and you want to be aware of Lambda. So the Lambda data architecture for Hadoop kind of has 3 different layers associated with it. One of them is a batch layer, and a batch layer is just simply an immutable source of the data. It's a copy of your data, how it originally appeared. And this is kind of similar if you're no data warehousing at all. This would be equivalent, I guess, to a PSA or a persistent staging area. And then you have 2 other layers. You have what's called a speed layer and a servicing layer. Now, the speed layer, it's going to have kind of some things like materialized views that get recalculated, let's say, every 2 hours. But it's not going to have real-time data. It's going to have data that might be, a couple hours old. But the reason that it doesn't have real-time data is because these calculations, if we calculated everything, it would never come back in time in order to get the results. So what we do is we pre-calculate the data, and we're able to get access to it very, very quickly, but we pay the penalty in that the data might not be the most current data. And then we have a servicing layer in Lambda. The servicing layer is going to have what we call batch views. And batch views do not have all of the detail of the batch layer. So it has a smaller size, and it also calculates things incrementally. So we might have in a batch view, we might have a series of counters. So whenever we get a new value, we just simply increment the counter by 1. But it has real-time data associated with it. Now, I'll let you, get more resources on Lambda, but it's something that you want to look at. So in addition to Lambda, there are kind of 3 other things that are kind of really important that you want to be aware of. One of them is Kafka. And Kafka is kind of like it's a publish, subscribe kind of system, right? So the thing that's neat about Kafka is it turns let's say if we're getting messages from someplace, it turns them into durable messages so that we know that we actually have something. For example, if you have a streaming process, if you have log aggregations, and you're getting, literally maybe 100,000 different log entries every second, Kafka can make all of those durable so that you can process them into your Hdfs, into your Hadoop environment. The other thing is Yarn, and we talked a little bit about Yarn with Hadoop 2.0. One thing that's really neat about Yarn is it enables you to implement additional things besides MapReduce. So you can cover the gamut. You can go, instead of Hive, which is kind of like reporting, you can go more towards HBase, which is kind of real-time queries. And then the third one that I want to talk about is you really want to know something called Spark that's coming on the horizon. And what Spark is going to do is it is going to have in-memory components that run a lot faster than the traditional Hadoop environment. One of the issues that we have with Hive is it's built upon MapReduce. And MapReduce produces a lot of I/O because it writes results to the disk. What Spark is going to do is it's going to eliminate those I/Os and it's going to write them to memory. So you're going to get, maybe 100 times performance speed of what you saw over Hive. So what I want to do now is show you a little demo of how you can kind of learn about Hadoop. So, how can I, start learning about Hadoop? How can I, get involved with it right now? Well, one thing I would suggest is go to the Hortonworks site, and I'll just simply type, excuse my AOL account, but and you can go to hortonworks.com. And what's really neat is they allow you to download their entire Hadoop platform, right? Free of charge. Okay, so I downloaded it, and you'll kind of notice here that it's about 6 gigs in size. So what you have to do is you have to go out, find a server. I would highly recommend a server with maybe a dual core type server or multiple CPUs, or one that has maybe at least 8 gigabytes of memory, preferably 16 gigabytes of memory if you can afford it. But those type servers, I mean, you can get them now, for under $1,000. One of the other neat things about Hortonworks is, in addition to letting you download, an entire Hadoop platform, they also have a whole series of tutorials. So they take you through, like, what is Hive? Here are some lessons. Here's some examples. Let's load some data, okay? Cloudera also has a Hadoop environment that you can download. The only issue I have with it is that it has like a 90-day expiration window on it, so you kind of have to keep on downloading it and load it. So I've downloaded the Hadoop environment. You'll notice here that I selected the Oracle virtual box as my interface to it. So what I'm doing here, it comes up with my Hadoop environment. And what I'm going to do is I'm going to just simply start it up. And this is actually starting up my my Hortonworks platform that I have out there. So you'll see it here starting up, and this takes a couple minutes. But if you can kind of see this, one of the interesting things here is you'll see each one of the different products starting up. But you also see some other databases out there. For example, right now it's starting up MySQL. You're saying, wait a minute, Mike, this is a Hadoop environment. Why is it starting up MySQL or Postgres? The reason is it stores metadata about some of the tables and some of the files in these particular databases. So they actually use relational databases as well. So you'll see right now it's starting up the name node. It's starting up Uzi, which happens to be, the workflow engine. It's starting up Zookeeper right now, and Zookeeper actually helps you out with high availability. So it's starting up Hdfs, which is your file system. It's starting up Yarn, so you'll notice that we have Hadoop 2.0 in this implementation. So as you can see, it's kind of very easy to get this to start up. We're starting up the resource manager that we talked about in Hadoop 2.0. and we're starting up Embroidery. Embroidery is kind of neat. Now, I'm going to show you an example of it, but you can kind of think of Embroidery. It's open source, but you can kind of think of it as OEM. So, you know, with OEM, you can get a description of all of the databases that you have in kind of a graphical format. That is exactly what Embroidery does. So you'll notice that everything started up okay. And what I'm going to do is I'm going to start up a Putty session here. You'll notice that if you want to create a Putty session, that the port number is 2222. So just heads up. The user, I'm just going to log into root, and the default password is Hadoop, all in lowercase. Okay, so this actually gives me, you know, a login. One of the neat parameter files that you want to know about with Hdfs is Hdfs Site Xml. And that's located in Etsy Hadoop config. So this is very similar, I guess. If you look at Oracle, like to Oracle Home, RDBMS admin, and if you were trying to find like the net.ora file or the SP file. So what we could do here, if we wanted to edit these directly, we could just simply you know, VI them. And we could actually change some of these manually if we wanted to. Now, another better way is maybe using OEM or Embroidery and using the GUI interface to change these, because we have a little bit better record when we use Embroidery. You'll notice in this case, I have a parameter out there called block size. Notice how big my block size is, right? So that's 128K, or not 128K, that's 128 meg that's specified as the block size. The block size for Hadoop is absolutely huge for DBMSs. So let's get access to my Hadoop environment. And to get access to it, what I can do is I can go to I can bring up some of my components, which I'm going to if I can learn how to type correctly. Oh. There I go. So this particular URL, you'll notice it's the name of the server ID, which is 127.0.0.1, but also I gave it another number. I gave it 8080, and that is Embroidery. So the default password for Embroidery, the username is admin, and then the password is admin as well. And Embroidery is going to give you kind of like a management tool, just like OEM gave you, of your entire cluster that you have out there. So it's going to allow you to manage your cluster, your data nodes, your Hdfs. You'll notice over here on the side, you have all of the services, all the different applications that you have, like Hdfs. Let's say if you wanted to manage, your Hdfs, and you wanted to change, let's say, a particular parameter, like, very similar to an init.aura parameter, I could come over here and I could go to the advanced section, and then I could come down here and I could say, okay, let me see the Hdfs site parameters. You'll notice here that when I click here, I could change the block size, for example. So if you kind of think of Embrari, and Embrari is the open source way to doing this, it's kind of an equivalent to an OEM or kind of thing for your Oracle databases. Remember, the number is actually 8080. So now there's another one that I want to show you is 8000. And this is actually the interface. It's something called Hue. And what Hue does is it gives us kind of an easy way to import data files. It also gives us an easy way to access like Hive, Pig, Hcatalog. So what I'm going to do is I'm going to demo this out a little bit for everybody, just kind of show you like Hue's file browser that we have here. So for example, what I'm going to do is I'm going to delete a file that I loaded out there. And I'm going to actually import it back in so you can kind of see how really, really easy it is to upload a file. So here I just go Files. I'm going to select Files. And it's just simply a flat file that I have there, separated by commas. So boom, that loaded Dividends A CVS into the Hadoop environment. You can kind of see it was actually pretty quick. One reason it was quick was that it was a relatively small file. So loading these files, it's kind of pretty easy, right? If you use Hue. If you click on it, you can actually see what the particular data file looked like. Now, in addition to Hue loading the data, there's something very important called Hcatalog. Now, what Hcatalog is going to do is Hcatalog is going to show you, it's going to create an abstraction layer for you. So if you kind of look here on my screen, you'll notice that using Hcatalog, I don't have to give it a specific address for the data files. So it's really important to use Hcatalog. It kind of creates an abstraction layer, and it's very easy to use. You just simply type on Hcatalog, and what I'll do is I'll drop this particular one, Dividend A, and I'll reload it into Hcatalog. But you kind of see that Hue has a graphical interface that makes things kind of pretty easy to do. So we're going to create a new table. That table is Dividend A. And I'm going to choose a file, and that's the file that I want. So you can kind of see here that it gives you the column names in those files. Just remember also that when you load this data file in, be very careful of some keywords. One of the keywords is date. So just remember you can't use date. That's why I have DT there. So, and then I create the table in Hcatalog, which will take a couple minutes to process. So I would highly recommend using Hcatalog. Hcatalog is going to create that abstraction layer for you. And it just simply makes it a lot easier to use. Hive and also use Pig. So in just a second, after this is finished importing the data, I'm going to go over and do a demo of Hive as well. Hive is our kind of our SQL Plus interface. So if you know SQL Plus and you know ANSI SQL, you're about 90% of the way there. Now, just remember that they are constantly updating Hive with new releases. So right now, it's not as fully functional as, let's say, an Oracle RDBMS. But it has most of the commands there, and over the next year or two, you're going to see, pretty much the owner equivalent to, let's say, Oracle's SQL Plus. And there it's finished loading the data. So in order to go over to Hive, we just simply go over here. And we go over to the query editor. And one thing that I could do here really quick is I could just simply count the number of rows that I had out there. So I could just simply say select star. And if I wanted a reminder of all the tables that are out there, I can see the table. So I want to do dividend A. So select star. Dividend A. And then you just come down here and execute it. Now, what's happening behind the scenes is it's actually creating a MapReduce program, right? And then it's executing that MapReduce program. Actually, here it's doing something a little different because I have one of the features enabled called TES, and TES is something very similar to MapReduce. It's a Hortonworks specific product, but it's open source. That replaces MapReduce, and it eliminates a lot of the I/O and puts things in memory. But you kind of see my results here. My results, I have 8,719 rows. So if I go back to the query, one other thing that I can do here is I can click on Explain. And this is something you're going to need to know about for performance. What it does is it gives you an explain plan. Now, why is this important? Well, Hortonworks supports the cost-based optimizer. So this particular query that I'm running now is probably a little better explanation about that. But what you could do is you can select different types of joins. You have a shuffle join. You have a broadcast join. And with the cost-based optimizer, you might select one join technique over another, depending upon how your data is actually stored. So that's a little demo of Hive. It's fairly easy to use once you've actually used SQL Plus before. But another thing I want to show you about is I want to talk a little bit about PIG. And I guess PIG would be kind of like the equivalent of PL SQL, if you would. So PIG is used a lot in the transformation of data, just like you would use PL SQL maybe to transfer in your ELT programs. One of the neat things that it has out here is it has something called a PIG helper. And you can come down here and you can kind of use it. It uses it as like a template on some of the commands. So you have like all the different math functions. If you want to load data from all the data that you've loaded in HCatalog, it's real easy to copy data in there. And I created a couple programs here using the PIG helper. In this particular program, it's a real simple program. It's loading a table called stock A, and it's putting it in a memory area called stock A, and then it's just simply right here, it's limiting the amount of rows that I see to 100, and it's going to dump those results out to my sysout, which happens to be, in this case, just simply my output. So I'm going to execute this, and kind of give you an idea on how to execute a pig program. It takes a little bit of time to run. One other thing that you might notice with the Hortonworks implementation, make sure that when you use this particular parameter called use hcatalog, if you're using hcatalog, and one thing that you have to know is you have to enter that, and then you have to hit the enter button in order for it to take. A lot of people sit there and they just simply type it, and they don't hit the enter, so it doesn't take. So you'll notice here that it's finished, and I can come up here to query history, and I could actually see the results. And there I have my 100 rows that were dumped out. So I've written another program as well. This one actually dumps a file into a file called join stock tables 4. And I wanted to show you what happens when you actually execute this. And you have right now I have a duplicate, I have a join stock tables 4 out there currently. So if I execute this, this should come back with an error. So kind of gives you an idea of what happens when you have an error. And some of the error messages that you get aren't exactly real intuitive right now for pig, but we can show you an example of that. So if I come over here to query history, it tells me that it failed, and then I can go over here to the logs, and I can kind of go to the bottom here, and it kind of tells me in a cryptic manner that it failed to write it to the output file, and that was just simply because I have a duplicate file out there. So if I change that to a new file name, it will run for me. So the thing that I wanted to show you was when you get an error message, sometimes you need to go to the log, and the log right now you can kind of see is kind of very, very cryptic in nature, if you would. So that's my demo of Hadoop, but I do want to go back to the presentation. And I want to talk about NoSQL, and I want to talk about the Oracle in-memory database option that I have here. Now, NoSQL is a little bit different than Hadoop. So NoSQL, you have different types of NoSQL databases, but you have columnar databases, you have document, key value, and graph. Those are the 4 main categories of NoSQL. But Gilbert and Lynch came up with a theory called a CAP theory. And what CAP theory says is for a NoSQL database, for a specific database, you can only get 2 out of the 3. So consistency means that all data nodes see all the data at the same time. Availability, you have a guarantee that every request receives a response about whether it was successful or failure. And you have partition tolerance. So partition tolerance means that the system will continue to operate if you lose one of the shards, or if you lose one of the, let's say, the working part of the system. So because I only have 2 out of the 3, some of my databases that I might store things in NoSQL, like let's say Cassandra, don't have a consistent guarantee. They have a consistent eventually guarantee, but they don't have a consistent guarantee like Oracle does. So potentially, depending upon the updates of the system, you run 2 reports, and depending upon what nodes they are, they might get 2 different, slightly different results. Okay. Now, however, because Cassandra doesn't have a consistent guarantee, it has a consistent eventually guarantee. what that means is it can be a lot faster in returning results. So I did want to talk a few minutes about something that I think is really, really cool, and it's called the Oracle in-memory database option. Now, it's a feature of Oracle, which means that you have to pay for it. Very similar pricing to, let's say, partitioning. But what's really, really cool about it is it's a different memory area that you allocate with your Oracle SGA, and it essentially turns your Oracle database into a NoSQL database. So what it means is you can, let's say, simplify your data models. You can eliminate index structures. And what it will do is it will compress the data down into a columnar format. So it takes those rows and breaks them into columns. And because it's a column, it can compress the data much more readily than it can a row. You know, if I have 500 Michaels, it's really easy to compress the data down. And then what it does is once it gets that data compressed, it puts it in memory. And the whole idea is not to use a lot of indexes, but to run everything in parallel to access your data. And it's kind of really neat because in order to implement it, it's really, really easy to implement. And you don't have to change a lot of your application. This is a physical construct, not a logical construct, so you don't have to change your SQL statements at all in order to gain access to this, in order to take advantage of this. Now, one of the other secret sauces about this is it uses something called vectorization. And what's really cool about vectorization, it uses the memory on the CPU, which is really, really cool. A few years ago, you know, maybe a decade ago, we had a problem with gamers. You'll kind of see it with TV sets when they had maybe a sports program on it, and you kind of saw jerky motions in the result set. So what they did is they created a chip, and that chip, instead of processing one particular pixel at a time, it did 10 at a time in a single clock station. So it came up with something called vectorization. So what they came up with was, hey, why don't we use this instead of with pixels, comparing other data values? And that's what Oracle did with the in-memory database. It's able to take advantage of the memory and the CPU to do processing, to do vectorization. So in a single clock motion, it's able to compare maybe 10 things at once. And the results that you get by using the CPU and the fast memory on the CPU are absolutely amazing. At a particular company that I was working with, we had a lot of Exadata machines. And you can use the in-memory database option with Exadata as well. But what we were doing is we were trying to eliminate Exadata as much as possible because Exadata was pretty expensive. So instead of buying an Exadata machine, what we did was we bought a generic HP Linux server. You know, that was we bought, you know, a top-of-the-line model for under $100,000, and we implemented the Oracle database option, and we were absolutely amazed with the results. We got anywhere between 5 and 10 times compression. And we also got queries that ran 2 or 3 times faster than the Exadata machine itself. So we were actually able to use the Oracle in-memory database option and actually get speeds that were fast. For the most part, we had 1 or 2 queries that we had to go back and figure out what was going on. But for the most part, we saw amazing results by going to just simply commodity hardware. But we used the in-memory option, and it was absolutely amazing as far as some of the speeds that we were seeing. Now, the speeds that we saw were directly related to analytical queries, okay? We actually put a couple online transaction systems on here as well, but we saw a little bit of improvement in performance, but not much. You're going to get the biggest bang for your buck is in terms of analytics. And I was talking to another author that co-authored my book on the Oracle OLAP solutions. And we actually think it's so amazingly fast, right? I mean, we're seeing anywhere between 10 and maybe 1,000 times response time on some of these queries over the generic hardware we had with our normal Oracle databases, that you could actually use this in-memory database option maybe to get rid of your OLAP environment, maybe not to have an extensive like Essbase environment out there if you would. Because it stores things in columns, there are certain filters that you're going to see out there. One's called a Bloom filter that whenever you see that in terms of the execution plans, you'll see it amazingly go fast. Also, when you have these columns, it's a lot faster on the joins of the columns. In order to actually implement it, it's actually pretty easy to implement. You just simply, change some of the init.org parameters. You tell it the in-memory error, and then you tell the tables, each one of your tables, or maybe even a partition, that you want to use the in-memory option, and it basically takes it from there. There's not a lot of tweaking that you had to do. When we ran this in real life, there were only about 1 or 2 queries that we had to go back and figure out, a different execution plan. But for most of them, things ran, amazingly fast. Okay, that's the end of my presentation. And today, I just kind of wanted to give you a feel. If you're an Oracle DBA, you're going to have to recognize Hadoop. Hadoop is going to be radically changing things over the next 5 or 10 years. And as an Oracle DBA, we have to adapt. We have to learn new things constantly. And hopefully this gives you a little better idea about what's currently out there in the Hadoop world. So, Armin, do you see any questions that we might have?
Yes, let's go ahead and take some of these questions. I had one question, or there is one question posted previously in one of your slides. You talked about using port number 2222 for the Hadoop. Is that port number fixed, or are you able to set that port to whatever number you need it to be?
You can change it to whatever one you want to change it to, but that's the default one. So okay. If you're setting up like a Putty session, just remember that it's 2222. So.
Okay, and you talked about the block size, 128 meg block size. Is that a recommended best practice, or does it depend on something else, or is there different sizes?
Oh, just like with Oracle, right? But block sizing is one of the critical components of Hadoop. Okay, so it's something that you want to think about, something that you don't want to tweak without thinking about. And the reason is Hadoop has something called split values, which what it does is it looks at the block and it figures out how many threads per block, right, that it's going to spawn off. So you kind of have to be careful, because if you have a big program that maybe has 1,000 blocks associated with it, right? And you have 8 meg block sizes and your split size is 4. You might be attempting to spawn off 2,000 threads, right? So your block size is very, very critical in Hadoop for performance, right? So some sites I've seen, they try to reduce their block size really, really low to get a lot more threads, right? So they were running the Cloudera environment where they had a fair scheduler. So they were trying to get as much resources as possible. So they reduced down the block size. But you want to be careful in doing that, because you can affect the overall performance of the cluster. So the answer is yes. You definitely want to think about your block size up front. And you want to be aware of the considerations, right? So when you test things out, you might want to test it at 128 meg, or you might even go a little lower, but you might go higher as well. It's not uncommon to have like 256 megs for a block size on a real cluster, not my PC.
Okay, thank you. Another question is, if I implement a big data architecture, do I still need my data warehouse, my Oracle data warehouse?
Absolutely, right now. The two are, you have two different environments. So you have your Oracle data warehousing and environment that you still have out there, but there are certain things right now in big data that don't fit very well in your Oracle data warehouse. So, for example, log files. All of your interactions with your customers, they fit a lot better in your Hadoop environment. So you have kind of two different environments, and sometimes they're communicating back and forth all the time as well, right? So in the Hadoop environment, you have right now a lot of interactions. So for example, you might have all your log or your clickstream information, but in your data warehouse, you might have customer information, right? You might have your MDM file on a profile for your customers still. And you actually might move data back and forth for performance. You might copy it from one environment to another. But right now, you definitely have both environments coexisting. But in the future, it's my opinion, and this is my opinion only, you're going to see a lot more of that enterprise data warehouse that we might store in Oracle right now. You're going to see a lot more of that go to the Hadoop environment, and that's just simply based on cost. These Hadoop environments are a lot cheaper. For example, I was able to eliminate. There's an appliance out there called Netezza, and we were able to eliminate 2 Netezza boxes, which cost us over $2 million, with an equivalent Hadoop structure that only cost us $250,000. So it was not quite 10 to 1, but almost 10 to 1 as far as the cost, which is why, in my opinion, 5 years from now, you're going to see a lot more of the data warehousing go to Hadoop.
Thank you. And for big data and privacy, is there any tools out there like there are in the Oracle product suite that allow you to encrypt data or protect the data?
Yes. Yes. There's data encryption. Okay. Cloudera has another corruption tool that they use, but it's essentially based on RSA. So you can, encrypt all of your data locally, and you can keep the, your keys. So, nobody else has to know about that if you don't want to. So the answer is yes, there are tools.
And lastly, what would you say is one of the most what would you say is one of the most important considerations when you decide to implement a big data architecture?
You have to do it incrementally, okay? And you have to get people up to speed on the use cases for Hadoop. Because everybody says, hey, we need big data, and it's kind of an exciting time now. So they want to throw a lot of things on big data that might not be appropriate. So, for example, transactions right now, that is not a good fit for the Hadoop environment. Analytics, web, your log file processing, your streaming, excellent use cases. So getting people up to speed, right, on what Hadoop is, and you can kind of see here we had like 20 different, it's a polyglot type of environment where you have 20 different products as opposed to one product. So you have to really educate people about what specific product does what and what is appropriate. So, for example, Hive, right? Hive isn't really good for bringing back queries really, really fast, right? So if you're querying a single row in Hive, it might take 2 minutes. If you're trying to bring back an entire report in Hive, it might take 2 minutes, 1 second. Okay, so it's not really dependent upon the amount of rows that it brings back, right? So you might have a different approach that you might have Hive, but you also might have something like Spark SQL, where everything is in memory, or you might have Hbase, so that you could have that real-time query. So educating everybody on the Hadoop environment, the Hadoop architecture, and using the right tools appropriately, I think is one of the biggest components.
Okay, thank you. You want to go to the next slide, Mike? So I hope everyone enjoyed, got something out of this presentation. I want to thank Mike for taking the time to do this as well. If anyone has any additional questions they think of after the presentation, they can feel free to contact us at the oracle@neovera.com or sales@neovera.com. And we will post this presentation up on our YouTube site, our YouTube channel, if you wanted to share this with other coworkers that may not have had a chance to view it. So again, thank you for everyone for attending. This concludes the presentation.